I am recording. Ladies and gentlemen, if you can stop talking, I'd appreciate it. All right, so hopefully you figured out your root. We did that together, and we figured out that our root was y equals negative 1x minus 5. Hopefully you were able to graph that. Over here, we need to change these into slope-intercept form. So I need to get the y's over here and my x's over here. So I'm going to subtract x and subtract x here. That gives me 0 equals 3y minus 15 minus x. I need to get the y's over to the left. So subtract 3y. I have negative 3y equals negative 15 minus x. Divide by negative 3, divide by negative 3, divide by negative 3. And I get y equals 5 plus 1/3 x. So my slope here is 1/3. And my y-intercept here is 5. Okay? So everybody see how I did that? Is anybody paying attention? All right. The next one, enemy ship 2, its route is 4x minus y equals 7. I need to move 4x to the other side. So I will subtract 4x, and I get negative y equals negative 4x plus 7. I do not want negative y, so I will multiply by negative 1. I have to multiply everything by negative 1 and use distributive property. And I get y equals positive 4x minus 7. So that is enemy ship number 2. Here's enemy ship number 1. The last one is already in slope-intercept form. I can just rearrange it a little. Y is equal to negative 2x minus 1. Okay? So those are the 3 equations. All right?
Subtracting negative 4x from both sides. And then she was left with y equals negative 4 because it transfers over to the other side, the equal sign.
I like the discussion. That's good. So those are my 3 equations. This is probably what your graph should look like. Something like this. Okay? How did you figure this out?
How do you get negative 1 for the equation?
Because it was a negative 1 here.
No, for only 2.
For number 2, because it was a negative y value and I don't want negative y. So I multiply it by negative 1 to get the positive y. So then I have to multiply everything on the other side by negative y or negative 1 to change and get those opposites. So right here, I multiply by negative 1, so I multiply here by negative 1 also. And then distributed that negative 1 with those. Okay? So everybody who's working on this, please listen, because I am not impressed with everyone's work ethic today. I know it's a little crazy because we've got people taking tests, people doing reviews. I want you right now to write down these 3 equations if you don't have them already, because we're almost out of time. Please write these down. I want you to plot them on your own at your house somewhere, because I don't think many of you have many of those plotted. Okay? Should look something like this. Do you need the equations again? Should look something like this. Maybe you want to take a picture and see what it's similar. And then if this is your route, where are you going to plant the bombs? Now, you cannot just jump over here and plant a bomb over there. That is not the journey that you are on. So you want to plant these bombs wherever they're going to do the most damage. Okay? So hopefully we'll have a little bit of time to talk about that tomorrow. For this next unit, this is systems of equations. Systems of equations. So we had linear functions, equations. Now it's a system. We're talking about two or more equations on a coordinate graph. There will be a project. This project is due the 27th, okay? Usually you won't get too much information about the project to the end because it's pretty comprehensive, all right? So for tonight, graph these and tell me where would you put these bombs. If you guys are working on the test, don't worry about it, okay?